Hello everyone. I'm Ranjitha, working as a mathematics lecturer at Government PU College, Hiriyadka. I welcome you to the today's session. Today I'll start up with sets, relations and functions. As you all know, set it is a well-defined collection of objects, and set is denoted by capital letters like A, B, C, etc. Elements of the set is written within the flower bracket separated by commas. You can use letters, numbers, diagrams as the elements of the set. Number of elements in the set is considered to be the cardinal number denoted by n of a. Then we consider types of sets. We have learnt about singleton set. It is a set with only one element. Empty set, it is a set without any element denoted like this. Or you can use a Greek notation phi. Next we'll consider finite sets. It is countable. Number of elements in the set is finite, so it is called finite set. Otherwise it is called infinite set. Next we have studied about equal sets. Suppose if we consider two sets, A and B. In the set A, I'll consider two elements, A comma B. In the set B, I'll consider two more elements, C and D. But here, we cannot say that A and B are equal sets because only the number of elements in the two sets are equal, but elements are different. So, set A equal to set B only when cardinal number should be equal and elements should be same elements. Means every element of A is an element of B and every element of B must be an element of A. Then only we can say that they are equal sets. Now we'll consider set operations. We have studied about set union denoted like this, set intersection, then difference of the sets A minus B, and we have studied about B minus A also, and complement of the set. All these things we have studied. So set union, if we consider two sets A and B, then set union is A union B. It is a set containing elements X such that X belongs to A or X belongs to B. X belongs to A or X belongs to B. If we consider set intersection denoted like this, it is a set containing elements X such that X belongs to A and X belongs to B. This means the element should be there in both A and B, means it is set containing common elements of A and B. Then consider A minus B. Here it is a set containing elements X such that X belongs to A, but X does not belong to B. X belongs to A, X does not belong to B. Next we'll consider two formulas related to cardinal number of the set. That is n of A union B, n of A union B, that is equal to n of A plus n of B minus n of A intersection B. Suppose Set A and B are disjoint sets. Disjoint sets means intersection will be null set. So n of A intersection B equal to 0. So when A and B are disjoint sets, n of A union B equal to, see this portion won't be there. N of A union B equal to n of A plus n of B only. Like this, we can consider three sets also. N of A union, B union, C. This is equal to N of A plus N of B plus N of C minus N of A intersection B minus N of A intersection C minus N of B intersection C. Minus N of B intersection C and finally plus N of A intersection B intersection C. So this is the formula when we use three sets. Next we'll consider relations. Generally we'll use capital R to indicate a relation. Relation R, it is a subset of A cross B. Suppose if we consider set A and set B are the two non-empty sets, we know how to write the Cartesian product of A and B, that is A cross B. Then R is a relation from A to B, means it is the subset of A cross B. So R is equal to, it is a set containing ordered pairs x comma y such that x belongs to A and y belongs to B. Y belongs to B. Now we'll consider number of relations possible. That is, as I said earlier, R is a relation. It is a subset of A cross B. And we know that number of subsets can be calculated using the formula 2 to the power n. Now it is the relation subset of A cross B. So number of possible relation, that is 2 to the power mn, where m is the cardinal number of A and n is the cardinal number of B. Next we'll go through type of relation. We studied about empty relation. We studied about universal relation, reflexive relation, and symmetric relation, and one more transitive relation. If the relation satisfies reflexive property, symmetric property, and transitivity property, that relation is called an equivalence relation. Next, we'll consider function. Suppose if we consider a function f, it is a mapping from A to B, means for all the elements of set A, which is called domain, there is unique image in the set B. Every element of A is associated with unique element in B. That element is called image. Set B is called codomain, and the numbers which are associated with the function from the set B, that is considered to be the range. When range and codomain are equal, we can consider that function as onto function. And one more we have studied about one function also. All those things you have studied already. Ma'am? Now we'll consider the questions one by one. All these are the synopsis, means basic things what you have learned in the regular classes. So we'll consider first question. The number of proper subsets of set A containing elements 1, 2, 3, 4, 5. Now observe here. Question is on proper subsets. So let us recall the type of subsets. One is proper subset, another one is improper subset. For any set, here it is with 5 elements. So number of possible subsets, that is 2 to the power n, where n is the cardinal number of A. Now it is 5. So it is 2 to the power 5. So we can write 32 subsets. 32 subsets. In that, you have to consider only the proper subsets. So what do you mean by proper subset? Proper subset means it is the set containing, properly contained in the given set, right? Number of improper subset is always 1. Remember, number of improper subset is always 1. Okay. So out of 32 subsets, if 1 is the improper subset, so the remaining all comes under proper subsets. So number of proper subsets, now it is 31. It is 31. So option 2. Second question. The set of intelligent students in a class. The set of intelligent students in a class. The options are like this. A null set. Second one, a singleton set. Third one, a finite set. Fourth one, not a well-defined collection. So this comes under not a well-defined collection because it varies from person to person, right? So it is option D. Option D, not a well-defined collection. Consider third question. In a hostel accommodating 200 students, 50 like coffee, 75 like upma, 35 like both. Number of students like neither of these. So let me draw the Venn diagram. Two sets are there. One related to coffee, other one related to upma. Now, out of 200 students, 50 like coffee, 75 like upma, 35 like both. So we'll fill up the intersection part in the beginning. That is 35 now. That is 35. So this will be 35. Okay. Now consider number of students who like coffee, that is 50. In that you have written 35 already. So this will be 15. Next consider upma, 75 is there. So this will be 45. Sorry, it is 40. So if you add all these three, 15, 35 and 40, that gives you union. That is C union U, that is related upma actually. That is 15 plus 40 plus 35. 15 plus 35 plus 40. that is 90. So this is union. But the question is neither coffee nor tea. So if you consider a rectangle outside this, that is universal set. In the universal set, you have 200 students. Out of the 200, you have to minus 90. Minus 90. So we'll get 110 as number of students who neither like tea nor coffee. So answer option second one, that is 110. Next question. If f is a real valued function defined by f of x equal to x square minus 16 under root of x square minus 16, then domain of f is, see the function is like this now, under root of x square minus 16. And we know that x square minus 16 should be greater than or equal to 0, right? Simplify this. We'll get x belongs to, actually after simplification here we'll get plus or minus 4. So x belongs to closed interval minus 4 to 4. So this is considered to be the domain of this function. Closed interval minus 4 to 4. So if you check with the option, this is set, cannot be. This is the interval form, minus 4 less than or equal to x less than or equal to 4. So this answer can also be written like this, closed interval minus 4 to 4. So answer option is B. Next question. The set A equal to, it is a set containing x such that x belongs to R and x square equal to 16. This is the one thing, x square equal to 16. And another condition is there, 2x equal to 6. So first simplify this. If x square equal to 16, x is equal to plus or minus 4. Plus or minus 4. Now consider second condition, 2x equal to 6. 2x equal to 6. So what is x? X is equal to 6 by 2, that is 3, right? Now, the word and is used, means both the condition to be satisfied. Now, check with the options. Check with the options. Both the condition to be satisfied, therefore, we don't have any common values here. Therefore, option is 5, null set. Consider next question. Which of the following is the empty set? First option, set containing x such that x is a real number and x square minus 1 equal to 0. This can be simplified actually. X square minus 1 equal to 0. So x square equal to 1. X is equal to plus or minus 1, right? That is a real number, holds good. So question is, you have to check with the empty set. So this cannot be the answer. Second one, set containing x such that x is a real number and x square plus 1 equal to 0. If you simplify this, x square equal to minus 1, then x is equal to root of minus 1, which is not a real number, does not belong to R, that comes a complex number part, imaginary, that is plus or minus I, like this. So that is under complex number section. So this is not a real number part. Therefore, if you list the elements of the set related to this, we won't get any element. So it is empty set. Like that, you can simplify third option also. That is x square equal to 9. So x is equal to plus or minus 3 comes under real number. And last one, it is quadratic. That also you can solve. So empty set is option B. Empty set is option B. Next question. A set A has 6 elements. Then maximum number of relation on A. A has 6 elements. Means n of A is 6. Relation as it is a subset of A cross A. So number of possible relation, that is 2 to the power 6 cross 6. That is 2 to the power 36. 2 to the power 36. Option C is the answer. Next question. The number of elements in the range of constant function. First, we'll recall what is constant function. A real valued function, f from R to R, defined by f of x is equal to c, where c is the constant, right? Whatever the value of x belongs to R, the function value tending to c, means function value equal to c. So only one number will get as the solution of this function, value of that function, right? So if we consider range of the function, we'll get only one entry in the set. So question is number of elements in the range of the constant function. So number of elements, it is 1. So answer option is B. Next question. A relation on n given by R is equal to ordered pair x comma y such that 4x plus 3y equal to 20. Which of the following does not belong to R? Which of the following does not belong to R? Now we'll check with all the options. 5, 0. So replace that value in the given rule. That is 4x plus 3y consider 4x plus 3y equal to 20. Consider 5, 0. Replace x by 5, y by 0. So if you replace x by 5, this will be 20, y is 0, we'll get 20 equal to 20. This belongs to, means holds good. Consider minus 4 and 12. Consider minus 4 and 12. Replace x by minus 4, we'll get minus 16. And 12 3s are 36. So we'll get 20 as the answer. This also holds good, means belongs to. We are checking with does not belong to. Now consider 2 and 4. Replace, consider 2 and 4. Replace x by 2, y by 4. Here also we'll get 20. This also holds good. Now check with the 3, 4. Check with the 3, 4. 3, 4. Replace x by 3, y by 4 in the function. This is 12. 3 4s are 12. This is not equal to 20. So the answer which is not belong to this rule, not coming under this rule, that is option D, 3, 4. Next question. A function f from R to R and a function g from R to R defined by f of x is equal to 2x plus 3 and g of x is equal to x square plus 7. Find the values of x such that g of f of x is equal to 8. G of f of x is equal to 8. So I'll consider that function only. It is a composite function. Go on simplifying one by one. First, we have to solve the term which is inside the bracket, that is f of x. So g of f of x is given, that is 2x plus 3. So here 2x plus 3, that is equal to 8. Now this is g of 2x plus 3. G function also given, that is x square plus 7. Now with us 2x plus 3 square of that plus 7 must be equal to 8. Now if we simplify this, 2x plus 3 equal to 8 minus 7, that is 1. That is 1. 2x plus 3 the whole square, that is 8 minus 7, that is 1. So take root 2x plus 3 equal to plus or minus 1. Therefore 2x plus 3 equal to 1. Simplify this, 2x equal to minus 2, x is equal to minus 1. Consider second case. This is one of the value we are getting. 2x plus 3 equal to minus 1. So 2x is minus 4, x is equal to minus 2. So this is another value. Now if you check with the option x equal to minus 1 and x equal to minus 2, that is option C. Option C. Next question. If f of x is equal to 2x square plus x plus 1 and g of x is equal to 3x plus 1, what is f composite g of 2? F composite g of 2. So if you simplify this, f of g of 2, that is f of, what is g of 2 now? See, g function is 3x plus 1, g of 2 now, 6 plus 1, that is 7. So this is f of 7 now, f of 7. So replace x by 7 in this function. 7 square 49 into 2, 98 plus 7 plus 1. Simplify this. We'll get 106 as the answer. So answer option is A. Next question. If x is not equal to 1, f of x equal to x square plus x minus 1 is a real function, then f of minus 1. So I'll keep f of as it is. Simplify this. F of minus 1. See here, f of x is x square plus x minus 1. So f of minus 1 is 1. This is minus 1. This is minus 1. These two get cancelled. So what is remaining? Minus 1. So substitute here. Again we'll get f of minus 1 only. Again substitute. We'll get f of minus 1 only. So if you simplify, we'll get minus 1 as the answer. So if you check with the options, first option, that is minus 1. Next question. The set of all natural numbers x such that 4x plus 9 less than 30 is equal to. You have to simplify this now. 4x plus 9 is less than 30. 4x is less than 30 minus 9. 4x is less than 21. So x is less than 21 by 4. We'll get 5 point something. A decimal value we are getting. But condition is the value should belong to set of natural numbers. So if we consider number line, suppose this is 0, 1, 2, 3, 4, 5, 6, like this it goes. We need natural number. See here, x is less than 5 point something. This is 5. 5 point means right side of that. So the natural number lying within this condition, that is 5, 4, 3, 2 and 1. 1, 2, 3, 4, 5. This should be the answer. So if you check with the option B holds good. X less than 21 by 4. Right? So answer is B. Next question. The set of all integers x such that modulus of x minus 3 is less than 2. Is less than 2. So if we remove this modulus sign, x minus 3 is greater than minus 2, less than 2. Go on simplifying. We need x value. So here minus 3 is to be eliminated. So add 3 throughout. So minus 2 plus 3, that is 1, less than x, less than 2 plus 3, that is 5. So 1 less than x less than 5 will get as the answer. Check with the options. X value is greater than 1 and less than 5. And condition is, it is coming under set of integers. So greater than 1 means it can be 2, it can be 3, it can be 4. Cannot be 5 because equality is not there. Only 3 values, 2, 3 and 4. So if you check with the options, option C holds good. Option C holds good. Next question. A is the subset of B. You know that this is a subset notation. A is the subset of B. Then B dash minus A dash is equal to B dash minus A dash is equal to. See here, if you consider A a subset of B like this, this is A. Consider this as B. A is the subset of B. Then B dash means, see, suppose this is a universal set. B dash means these values, right? A dash means these values. Except A, whatever there in the universal set, all those comes under A dash, means A complement. Now, we want B dash minus A dash, right? B dash minus A dash means element should be there in B dash. Element should be there in B dash, not in A dash. So this is to be eliminated, right? A B dash minus A dash means it belongs to B dash, not to A dash. So what is remaining actually? Only the outer entry. These entries are remaining, right? So answer option is B dash. Next question. If set A is equal to, it is containing two elements now. One is 5, other one is set 5 actually. Within the flower bracket we have written 2 elements. Then the power set of A. Now let me recall what is power set. Power set means it is a set containing all the subsets of the given set. It is a set containing all the subsets of the given set. So here 2 elements are there in the given set. Number of subsets we can write, that is 2 power 2, that is 4. So we have 4 subsets. So that comes in the power set, right? Now you have to check with the options. What are those? See, you have 5. So singleton set 5 you can consider. You can consider set with 5, that is this one, then given set and null set, because null set itself is the subset. So we have 4 elements here. So answer option is C. Answer option is C. Next question. If an equal to, see this is actually a suffix n, okay. An is equal to set containing ax such the notation this is set containing ax such that x belongs to n. Then the set 3n intersection 7n. 3n intersection 7n. Now first we'll consider 3n, okay. N is the natural number. multiple of 3 we need, right? So 3, then 6, then 9, then 12, then 15, then 18, then 21, then 24, then 27, like this it goes, right? Consider 7n now, multiple of 7. So 7n. So start from 7, 14, 21, 28, 35, like this it goes. So if we take the intersection of these two, just observe here, if we take the intersection of these two, we'll get, see, 7 cannot be, 14 cannot be. So the common element starts from 21 onwards, right? 21 onwards. See, this one and this one, like this it goes. So if you compare 7n intersection 3n, that is 21n. The set contains elements like this, multiple of 21. So if we check with the option A holds good, right? Next question. 25 people for program A, 50 people for program B, 10 people for both. So number of employed only A. Now, if we draw the Venn diagram, consider two sets, program A and program B. In that, first we have to fill both. Both here it is 10. Number of people employed to both A and B, that is 10. Now consider for the program A, 25 people. So you have written 10 already. This will be 15. Then consider B, 50 people. So you have written 10. So this will be 40, right? Now the question is only A, employed to only A. Only A means this region. You know that already, right? So N of only A, that is 15. That is 15. So if we check with the option, 15, that is first option. That is first option. This one. Next question. In a class of 175 students, the following data shows the number of students opting one or more subjects. Mathematics 100, physics 70, chemistry 40, mathematics and physics, that is 30, mathematics and chemistry 28, physics and chemistry 23, mathematics, physics and chemistry, that is 18. The number of students who have opted mathematics alone. So in this, we have to consider Venn diagram with three sets, mathematics, physics and chemistry. So first we have to fill up all the three, that is maths, physics, chemistry, that is 18. Then consider maths and physics. So mathematics and physics. Chemistry 40, mathematics and physics, that is 30. See here, mathematics and physics, this is the region you have to fill up, 30, but 18 is there already. So this will be 12. Next, consider mathematics and chemistry. Mathematics and chemistry, that is 28. 18 is there already. So this will be 10. Now, no need to fill all these things because we need only mathematics, right? So under mathematics, how many students are allotted? 100. Out of 100, you have to delete all these. 12 plus 18 plus 10. So 100 minus 40. So we'll get 60. So the number of students who opted only mathematics, that is 60. If you check with the option C holds good. Next question. Here n of u is given 20, n of a is 12, n of b is 9. N of a intersection b is 4. Where u is the universal set, a and b are the subsets of u. Then n of a union b complement. This is the question. So consider 1 minus n of a union b. So 1 minus, First calculate n of A union B, that is n of A plus n of B minus n of A intersection B, that is 21 minus 4, that is 17. So this is 1 minus 17, that gives you 3. So if you check with the option D holds good. Next question. In a class of 60 students, 25 students play cricket, 20 students play tennis, 10 students play both. Then we need the number of students who play neither tennis nor cricket, right? So for that, again consider Venn diagram for cricket and tennis. First fill up the number who play both, that is 10. Then number of students with cricket, that is 25. You have 10 already, so this is 15. Next for tennis, it is 20. You have 10 already, so this is 10. If you take the sum, 15 plus 10 plus 10, that is 35. 35, that is union, okay? That is union. Now we need neither cricket nor tennis. Therefore, from the universal set, means out of 60, you have to subtract 35. So that gives you 25. Option D holds good. Next question. The domain of the function f of x equal to x square plus 3x plus 2 greater than 0. X square plus 3x plus 2, it is greater than 0. If you factorize this is minus 3x. So x square minus 3x plus 2. If you factorize this, we'll get x minus 2 and x minus 1, one of the factors, two factors what are needed. So use wave curve method. I'll consider here the zeros of the polynomial 2 and 1. So consider 1, then 2, start like this. So as the condition is greater than, we need this region as the solution region, right? So this is from minus infinity to plus infinity. So if you consider the solution region, that is minus infinity to 1 open interval, union, this is not needed. Again this portion, that is 1, 2 to infinity, 2 to infinity. So if you check with the option, minus infinity to 1, union 2 to infinity, 2 to infinity. So option B holds good. Next one, A contains elements 0, 1, 2, 3, 4, 5 and relation R is defined like this. A related to B such that 2A plus B equal to 10. Then R inverse equal to. Before writing R inverse, we have to write R. Check with the numbers. If you replace x by 0, replace here. See, B becomes now 10 minus 2A, right? This is the rule. Replace x by 0, 10 minus 0, 10. This is not there in the given set. Replace A by 1. Then 10 minus 2, 8, not there. Then replace A by 2. 10 minus 4, 6 is not there. Replace A by 3. 10 minus 6, 4. It is there. So start with the 3, 4. Replace A by 4. 10 minus 8, 2. It is there. Replace A by 5. That is 0, right? So 5 is 0. This is R actually. So if you want R inverse, then read it reverse. 4, 3. Then 2, 4 and 0, 5. So option C holds good. Option C holds good. Next question. This we have solved already. There we have used numbers. So NA, it is a set containing element of the form n belongs to n. N3 intersection N5 is needed. So in the previous case, we have used N7 and N3. Now it is N3 and N5. If you take the intersection of that, The set contains like this. It is of the form N15. N15. So option D holds good. Question number 25. If A is equal to set containing 1, 3, 5, number of elements in P of A. Now, consider P of A. Power set of A. Set A has 3 elements. So, number of subsets 2 power 3, that is 8. So, P of A has 8 elements. Now, it is P of A. So, again 2 to the power 8. So, we'll get 256 as the answer. Option B holds good. Next, if two sets A and B are having 99 elements in common, then number of elements common to each of the sets A cross B and B cross A is 99 square, because you have 99 elements common. So if you write A cross B, we'll get 99 there. If you write B cross A, we'll get 99 elements which are common to both A cross B and B cross A. So option B holds good. Instead of taking 99, you can take simple examples with the 2 elements or 1 element, then check with the options also. Next, if n of A equal to 7, n of B equal to 10, and A is the subset of B, then number of elements in A union B. Now listen to me. A is the subset of B. You are taking union, so larger set will be the answer actually. So n of A union B, that is B, that is 10. So if you check with the option B holds good. Next one, the set A has 3 elements, 1, 2, 3, B with 3, 4, and C with 4, 5, and 6. So what is A union B intersection C? Now consider B intersection C. Common element to B and C now, that is 4. That is 4. So A union, the set with 4, right? So answer is 1, 2, 3, 4. So that is A union B intersection C. That is 1, 2, 3, 4. So if you check with the option B holds good. Next question. A and B are 2 sets. Then A minus B, union B minus A, union A intersection B. Now, if we consider the Venn diagram, A and B, this is A intersection B, and this is A minus B, and this region is B minus A. Now, if we take the union of all the 3, A minus B, union A intersection B, union B intersection A, that means this full region, that is A union B, that is A union B. If you check with the option A holds good. Next one, set A has 5 elements, 2, 3, 4, 8, 10. B has 3, 4, 5, 10, and 12. C has 4, 5, 6, 12, 14. Then A intersection B minus A intersection C. Now write down A intersection B. Elements common to A and B, right? So A intersection B is 3, then 4, then 10. 3, 4, and 10. Okay. Consider A intersection C. A with C. That is 4, only 4. 4. Now consider 3, 4, and 10 minus set containing 4, right? So elements belong to the first set, not to the second set. That is 3 and 10. Okay. But if you check with the options are not there actually. So just make a point of this. Answer is 3, 10. 3, 10. So this completes all the 30 questions. Thank you.